drop table if exists. So here if the table exists, it is going to drop the table, that is remove the table if it is available, right? Next, you are going for the next command, that is create a table with some name. Create table. It creates a table. You're searching for papers. It creates a table with a single column. It creates a table with single column of type string. Of type string. Next, what you're doing? You're loading the data into the file. Some file name you take down, write down. Load data. These you have to do in the lab. Load the data. In big data lab you have to do. Load the data in path. Load data is in capital letters. You have to give it in capital letters. Load data in path. Give a file name. So you're overwriting this particular file into the table called document. Okay, already you have created a document file with a single column. So you're overloading, that is you're overwriting the table with input file. So you can give your own file name. Overwrite into table. So write down there, it loads the specified file. It loads the specified file or directory. It loads the specified file or directory into the table. Overwrite specifies. Overwrite specifies that the target table. Overwrite specifies that the target table to which the data is being loaded is to be rewritten. So what are you doing here? The existing table is overwritten by another file. Clear? Otherwise, that is, if the table does not exist, so what it will do? It will just append the data. Otherwise, the data would be appended. So you're just going to do something like this. You're creating, overwriting, updating, or deleting that particular table. Clear? This is about HiveQL. Yes, next write down HBase. HBase. It is placed on the top of Hadoop file system. Right? HBase. Capital H. Base. It is a distributed It is a distributed column-oriented database. So it follows columns, not rows, right? Column-oriented database on the top of Hadoop file, on the top of Hadoop file system. So it is an open source. Right on. HBase is open source. HBase is open source and is horizontally scalable. Scalable means what? Scalability. It can be written in any form. Scalable means horizontally you're going to write the data, not vertically. Right? You're dividing it into a column base. Right? Next, write on. It is a model similar to that of Google's big table. Google's big table to access huge amounts of structured data. To access huge amounts of structured data. So here it provides read-write access. Right on. HBase provides read-write access. So here, why are you using HBase? To read or access the data from the HDFS. For that, we are using HBase. Clear? Next, you have a zookeeper. Put on the side heading zookeeper. What do you mean by a zookeeper? Yes. What do you mean by a zookeeper? In simple terms, I'm asking you, what is a zookeeper? Zookeeper. In the morning, I told you, why did he give the animals names? And now who is a zookeeper? You have to understand what you mean by a zookeeper. Now the zookeeper is nothing but, yes, stop talking. It also is used to keep the track of all these items. That is Hadoop, HBase, Hive, right? Spark, SQL, Spark, right? And Pig. So here, just put on the side heading zookeeper. Zookeeper is a distributed coordination service. So what does zookeeper do? It only keeps a track of whatever is being read or written into the Hadoop file system. Clear? There should be a person who should keep a track of, right? Then only it will work properly. So zookeeper is that. Right on. Zookeeper is a distributed coordination service that helps to manage a large set of hosts. Managing and coordinating managing and coordinating a service, especially in a distributed environment. Whose mobile is that? Give it here. Especially in a distributed environment, is a complicated process. So the zookeeper keeps the track. The zookeeper keeps the track because it has a simple architecture as well as API. What do you mean by API? What does it do? Application program interface. What does it do? No? What does API do? Interface అంటే ఏంటి? కనబడదా? Interface, simple, you are taking that you are the user and your system. How do you interact with each other? Operating system తీసుకోండి. How do you interact with it? It acts as a user interface, right? It will be as a coordinator between the user and the system. So here you are using application program interface, right? Based on that application, it is going to interact with you and the system. Clear? So here only the zookeeper, what does it do? It does not do anything. It acts as a column oriented service and it provides you distributed service. Clear? Because it has a simple architecture, it is going to provide you this service. Clear? Just write down. Zookeeper allows developers to focus on core application logic. Core application logic. Yes, next write down. Example. To keep the track of the status of distributed data, HBase uses Zookeeper. So what are the other services that the Zookeeper does is just here to retrieve the information, and it provides synchronization also. Next, write down features of Zookeeper. Features of Zookeeper. The first one is it is simple, that is simplicity. Second one is reliability. Now, what do you mean by reliability? In the morning, I told you. All this is one single architecture. Now, why does reliability come here? In the morning, I told you. Just read that statement and tell me what do you mean by that. And how can you say that it is reliable? Yes? How can you say that it is reliable? Read that statement. The system keeps performing even if more than one node fails. Amen. Yes, what do you mean by that? Morning we have discussed that. What is that? I told you about name node, data node. In that, what did I tell you? Only server? Only server? Here, even if the data node or the name node crashes, that is, it does not send the signal to the name node, what will happen? The heartbeat will be lost. How many times? Every time, how many times will it take? 10 seconds. Every 10 seconds, it is going to check the heartbeat. If it does not reply for 3 continuous times, what will happen? It will think that it is failed. So what does it do? It will take a new name node or the data node based on that application and will make it active. For what do we do that? Why do we do that? Because the data node will do the work of the name node. I gave you an example. What does it do? Whatever work is given to the data node, it has to do that work. So if you are not doing that work, will that system stop? Yes, you cannot stop that, right? It has to keep working every time. For example, you are doing trading now. Simple example. Let us take trading example. Do you know stock market and trading? So what do you mean by that? ట్రేడింగ్ అంటే ఏం చేస్తారు చెప్పండి? మార్కెట్లో మనం డబ్బులు పెట్టేసి స్టాక్స్ కొంటాం, రైట్? Yes. What do? We are going to take some shares there. Now, if I sit at home, say that I am not feeling well, will my shares stop working there? అక్కడ అది ఏమవుతుంది? అప్ అండ్ డౌన్ అవుతుంది, రైట్? If I don't work there, what will happen? Who will fail? I will fail, but my work will be done. Other work will be done parallelly there. So to keep that work to be done parallelly, we need to keep every name node available every time. So there are different data centers. Now the stock market is mainly in Bombay. So do we go there? No. So what do? We access them from our mobiles. Now if YouTube crashes, what will happen? Will you stop checking the stock market? Will you stop checking stock market if the YouTube fails? ఆ రోజు యూట్యూబ్ పని చేయట్లేదు ఒకరోజు, అప్పుడు మీరు సైలెంట్గా ఉంటారా? ఏం చేస్తారు? అదర్ సోర్సెస్ సెర్చ్ చేస్తాం, రైట్? ఇప్పుడు యూట్యూబ్ క్రాష్ అయిందంటే ఏమవుతుంది? మొత్తం ఎక్కడక్కడ ఆగిపోతుంది. లాస్ట్ టైం చూసాం, మండే రోజు ఏమైంది? మొత్తం ఫెయిల్ అయింది మార్కెట్ అంతా, రైట్? సో హియర్ ఇఫ్ దట్ సిస్టమ్ క్రాషెస్, యూ కెనాట్ వర్క్, రైట్? సో టు మేక్ యువర్ వర్క్ go on continuously, you have to keep some other name nodes or the data nodes active every time. Is that clear? That's why you're talking about reliability. Now here the zookeeper will keep the track of all these things what we have discussed in the morning. So it will take care of the Spark architecture, Hadoop. Next, what was that? MapReduce, Pig and Hive. Just it keeps the track of what is going on. Clear? Next, write down speed. Write down. It runs with the ratio of speed. It runs with the ratio of 10:1. Next, scalable. So this was 4th unit. Till now, do you have any doubts? We have done Hive services, right? Just an introduction about HiveQL. Next, what is a zookeeper? Then you have done Pig components, Pig architecture, and what is the implementation of Pig architecture? Yes, can you all tell me what is the implementation of Pig architecture? What was that? There are 2 components of Pig. What are they? Pig Latin and Pig execution. So what is the difference between both of them? What does Latin do? What does execution do? Girls, what does execution do? What does it do? Pig Latin, what does it do? What's the use of that? Yes? Just check your notes. What does Pig Latin do? I gave you 2 components, right? This is Pig Latin. Yes, these are the 2 components. See, in between, I have left all these things. You have to do all these things. Okay. I'll share you the notes. You have to do all these commands. That is, first one, you're using the grunt command to perform join function, right? You're creating the Hadoop file system in the local libraries. Next, what you're doing here, you're joining them again by using the different types of joins. You're doing right outer join, left outer join, union operator, right? Average, you're going to load the details and calculate the average CGPA of a student, right? Next, you're using concatenating command. Next, count. Next, you're using difference, is empty. Next, max function, sum. This one we have done. So you just put down the side headings of this so that later you can do all these things. Please write down this one. The join operator. Yes, join operator. Write down the different types of joins. Tondara andi. Write down the different types of joins. Write down self join, inner join, outer join, left outer join, right outer join, full join. Just write down this one. Grunt greater than. Yes, stop talking, girls. Grunt greater than relation 3 underscore name. You give some name there. Grunt greater than, boys, please be quiet. Grunt greater than relation 3 underscore name. So what you are doing here? You are joining the relation 1 by using a key and relation 2 by using the key. Which key do you use to join the tables? Foreign key or primary key? Yes? What are the two types of keys? Only two types of keys are there? Huh? Primary and foreign key. Secondary. Who is that? Huh? So you will use primary key and foreign key. So primary key is a unique key, whereas foreign key, the data will be available in the other table, right? You are going to link the two tables by using the foreign key. Write down that one. Join relation 1 underscore name by key, comma relation 2 underscore name by key. Example. I'm taking customer 3 and I'm joining customer 1 and 2 by their IDs. Next, what you are doing? I am removing customer 3. Remove customer 3, that is dump customer 3. So all this you need to do. Next, write down union operator. Yes, girls. Write down union operator. Write down the command and the example. Right. Write down the command and the example. What is the use of union operator? It will combine the two tables, right? Put down the example. What? Yes, stop talking, girls. Over. Next, you're having average function. Just write down average function. AVG function. Next, you have concatenate function. What do you mean by concatenation? Huh? Joining two tables. That is, the second table is attached at the end of first table. Right? Next one, count. We have used count function in architecture, right? Count. Next, difference. Difference function. Next is empty. So write down. This function is used to check. This function is used to check if the bag is empty. If the bag is empty. Then max function. Next, sum function. So we have done this. Okay, just see what we have done till now. Then we'll go for predictive analysis. Faster. Check what we have done till now. Those who have the notes, please check. చెక్ చేయండి ఏం చేసామో. I said put your mobiles inside. Now let us go to this problem. Let us do this problem first. Everyone, take down this one. Yes, stop talking now. Take down this question, all of you. This is in the 5th unit. First calculate this, then we'll do the predictive here, predictive analysis here. Write down. Find the regression coefficient. All of you, write down. Find the regression coefficient. Everyone has to solve this problem. I'll ask you the values, you have to tell the values. Find the regression coefficient for the following data. Take down the table. The table is having age and glucose level. Age and glucose level. Take down the contents of the table. Last black shirt. Yes. Now take down this formula. You have to find out, write down. Find xy, find xy, x square and y square values for all these for these values. So here age is x, glucose level is y. In the table, find out x square, y square and xy values for every row. Faster. All of you. Find out x square, y square and xy values. తొందర కానియండి. It is, see the values are 25, 90. Now is it clear? Take down the values. Age is called as x and glucose level is given the variable y. 25, 90. Next you have 30, 65, 35, 75, 40, 79. Next 45, 81 and 50, 87. Calculate x square, y square and xy values. So in this unit you will get direct question. This is called as regression coefficient. కానియండి. In the table find out x square, y square and xy. X square, y square and xy values. కానియండి తొందరగా. అయిపోయిందా? Did I give only two values? Did I give only two values? Where are the values? ఏందా కింద వాల్యూస్ రాసుకోవా? 45. అయిపోయిందా? వాల్యూస్ వచ్చాయా? మళ్ళీ ఏం చేస్తున్నారు? ఎంతసేపు కానీ 25 స్క్వేర్ ఎంత? 625 కదా. మళ్ళీ రాయి. చెయ్యి మళ్ళీ ఫస్ట్ చెయ్యి. చేసిన తర్వాత దాని ఫార్ములా వేసి వాల్యూస్ ఫైండ్ అవుట్ చేయాలి. ఫస్ట్ అది whose mobile is ringing? Yes, stop talking. Yes, have you found out? Then find the total value of all of them. That is the total of age, total of glucose level, next x square, xy and y square. Calculate them. అది కాదు నేను అన్నది, ఇది యాడ్ చేయమంటున్నా. కాలం యాడ్ చేయమంటున్నా నేను. ఇదంతా యాడ్ చేయి, మళ్ళీ ఇదంతా యాడ్ చేయి. ఎక్స్ యాడ్ చేయి, వై యాడ్ చేయి, ఎక్స్ వై, రైట్. ఇది ఇవి చేయి. Write on. Yes, stop talking. Write down the formula here. See here, you have to find the formula using, write on, y is equal to ax plus b. We need to plot the graph now. Y is equal to ax plus b. So here you'll do two types of regressions, linear regression and multiple regression, right? Before that, you are going to plot a graph for coefficient regression. Okay, you're going to find the coefficient value. So here write on, y is equal to a into x plus b, where a value is a and b are constants. You will be given a and b values, where a and b are constants, where a is equal to 0.211b, sorry 0.2114, and b is equal to 71.57. Now calculate y. Y is equal to ax plus b. What is total of x? Yes. Calculate y. Y is equal to ax plus b. What is y you have got? Y value. Y is equal to ax plus b అయిపోయిందా? A into x. What is x value? 225. అంతేనా? Plus b. So a value is 0.211 into 225 plus b is equal to 71.57. Find y value. What is y value now? 119.135 వచ్చిందా అందరికి? Now put a graph. Put the graph. Put the graph. Write on in the x and y. X intercept and y intercept. Write on x values, that is 0. What is given in the question? 0, 20, 30, 40, 50. Right? X intercept is 0, 20, 30, 40, 50. And then y intercept you write down. What is y? Maximum is 90. Now plot the graph. How will you plot? At x, y value, plot it. That is called as regression coefficient. Next we will do linear and multiple regression. Kaniyandi. How will you plot? At 25, the value is 90. Right. Etla cheyadu. Yes, what happened? Completed? Change. How will you put the graph? ఇక్కడ ఉన్నాయి కదా అది ఎందుకు నీకు రాయి 20 30 40 50 ఇక్కడ రాయి 0 20 30 40 50 అయిపోయిందా y వాల్యూ వచ్చేసి ఎంత ఉంది 19 ఇంచ్ సారీ 16 ఇంచ్ కదా 0 60 70 80 90 ఇప్పుడు ప్లాట్ చేయి 25లో ఉన్నప్పుడు దాని వాల్యూ ఎంత ఉంది 90 ఇక్కడికి రా క్రాస్ పెట్టు నెక్స్ట్ వాల్యూ పెట్టు అట్లనే సేమ్ ఎస్ లైన్ జస్ట్ స్ట్రైట్ ఇట్లా ఇది వేసుకో తక్కువ వచ్చిందా So this is called as regression coefficient. First ఇది చేయాలి. Next we will do linear regression, multiple regression. For that you require x square, y square, xy values. We have done that. Just put that plot. So here in this predictive analysis, what you are going to do is, what do you mean by prediction? What is prediction? ఏంటి prediction అంటే ఏంటి? You are going to expect what is going to happen further in the future. So now what you have to do is, you have to do predictive analysis. Okay, for that you need to create charts, plots, bar graphs. గుర్తున్నాయి కదా charts గుర్తున్నాయి. What are the types of charts? అవి plots, charts అంటున్నాను నేను. Line chart, pie chart, bar chart. ఇంకా plots, flow chart. Scatter plots ఉంటాయి, right? Next you have histograms. So all these things you have to do by predicting using regression coefficient and linear regression and multiple regression. Clear?